This is my alternative mastery video for BCR 4.2. So, this covers understanding half-lives by analyzing data to determine the value of the half-life, and understanding half-life values are used in radioactive dating. So what exactly is a half-life? Well, it is the amount of time it takes for a radioactive or unstable isotope to fall to half of its original value. So the best, a visual aid to do this is that suppose this is a radioactive isotope, a sample of radioactive isotope, and it has 100 atoms in it. Well, to find the half-life, first we're going to do 100 divided by 2, and 100 by 2 is 50. So each of these samples are going to be 50, but we're going to focus on this one for now. Now divide that by 2 again, and you get 25. You notice that each of these will be equal to 100 because the law of conservation of mass states that mass cannot be created nor destroyed, only transformed. So in this example, this is a chart related to the diagram. So I like to make a chart just to help me understand and solve this. So right now, since at the beginning, no time has passed. So that's why it's 0, and therefore half-life will be 0 because no time has passed. And we're starting out with 100 atoms. Now, when you do half-life, you have to divide the original sample by 2. So 100 divided by 2 is 50, which we put right here. That means it's been 1 half-life. So we're going to put a 1 right in this column. So I'm going to tell you that right now that the half-life is 5 years. So since it's been 1 half-life, it's been 5 years. Now we're going to take 50 and divide that by 2 again, which is equal to 25. Since the half-life is 5 years and it's been 2 half-lives right now, 5 times 2 is equal to 10. Now, so 25 divided by 2 is going to be equal to 12.5. Well, that's going to be our third half-life. So 5 years, which is a half-life, times the number of half-lives it's been. So 3 times 5 is going to be equal to 15. And that's how long it's been right now. It's important to know that we're only dealing with half. So you might be wondering, where did the other half go? Well, the other half converted into a more stable element. So it's time to try some examples. So sodium-24 has a half-life of 15 hours. How much sodium-24 will remain in an 18-gram sample after 60 hours? Now we're going to make a chart again for this. So in our time column, we're going to start off with 0 because we just want to look at no time has passed. What are we starting with here? So the time column is going to be 0. And since the time column is 0, we're going to have the half-life column 0 because no time's passed. And our sample is starting off with 18 grams. Now, what will be next? Well, we know 1 half-life is going to be equal to 15. So in time is going to go 15. Well, 18 divided by 2 is 9. And then the half-life column will have 1. So since it's been 1 half-life, which is equal to 15, and you divide the original sample by 2 to get the half-life of that. So right now we have 9 atoms in 15 hours. Do that again. Now it's been 2 half-lives, so it's 30 hours have passed. So 9.0 divided by 2 is 4.5. Repeat that one more time. Well, 2 more times. So now this time, we're adding another half-life. So 30 plus 15 is equal to 45. And it has been 3 half-lives. And 4.5 divided by 2 is 2.25. Now this is a final step. So 45 plus 15 is equal to 60 hours. 2.25 divided by 2 is equal to 1.125. and it has been 4 half-lives. So the answer would be 1.125 atoms, well, grams. So that's how many grams we have now. Time for a second example. A rock formed with 1,000 atoms of a radioactive element, but only contains 250 radioactive atoms today. If the half-life is 1 million years, how old is the rock? Once again, we're going to make a chart. So this time we have to solve for the age. So we're going to have to solve for the time column. So we're starting off with 0 half-lives, no time has passed, and we're starting out with 1,000 atoms. Half of 1,000 is 500, so we're going to fill out 500 now. Since the half-life is 1 million, in the time column we add a million since it's only been 1 half-life. Now, do it one more time. 500 divided by 2 is 250, which is how much it contains today, according to the question. So we want to know how old is a rock. Well, 1 million plus 1 million is equal to 2 million, and it's been 2 half-lives. So the answer would be 2 million years. That was my alternative mastery video. Thank you.